How's it going, everybody? And welcome to Module 2 of our VMware VCA certification exam video series. What we're going to talk about now is the components of what makes up VMware vSphere. So we'll explore the different features and components of vSphere and things like that. So when we get done with this part, you should be pretty confident with at least having a fundamental understanding. Fundamental meaning you will know what vMotion is and kind of the backstory behind it. That's just one piece of the puzzle anyway. So one is it supports data center virtualization. So we'll learn about virtual machines. Virtual machines themselves, from the outside, the virtual machine or VMs look and behave just like physical servers. So if you're on one, you really don't know the difference unless you know it's a virtual machine. You can't physically tell by looking at the operating system or poking around inside of it by opening different windows and things like that. It may be difficult for users to distinguish a VM from a physical server, but there are some subtle differences that make them unique and very useful in the data center. Like in Module 1, the hardware of a VM is really software. So as long as you can understand the abstraction layer with using the VM kernel to take the hardware and virtualize it so it can be put into a software resource for a software computer or a virtual machine, you're pretty far along already. End users may not care about this. It gives you and I a number of advantages, such as the ability to replace and upgrade components of the virtual machine on the fly. So normally it would be pretty time consuming for you, the admin, to walk to a user's computer, have them close everything out, shut the power, turn the operating system off, then open up the box, add the memory, pull out the hard drive. You don't have to do that with VMware. You simply turn the VM off and you right click on it, and if you haven't already added or clicked on the hot add or remove option, and you can add hard drive space or memory or CPUs on the fly. So makes it that much easier. Virtual hardware also allows you to add new hardware devices such as network cards and processors without rebooting the VM. So in Workstation you sometimes have to, and there's some limitations to it, but when you're working inside of Esxi itself, you don't have to do that. Ultimately, virtual hardware can help reduce your downtime because you don't need to reboot your VM every time you upgrade. You can do an upgrade on the fly. So VMs are virtual hardware, so you're not going to use up space in the DC. Dedicated virtual hardware also means that VMs are just as safe as physical hardware. So what that basically means is you can have a server like the one I'm tapping on, and that server can hold maybe 10 or 12 virtual machines. The one that I'm working with right now has 2 already working on it. Normally I would have to have 2 physical servers in order for that to work. A domain controller for one box and a member server for something else. Well, I don't have to do that because I'm virtualizing it. So what can a VM do? Well, it's actually quite a bit once you get really into the meat and potatoes of what's going on. VMs can be used to host any application from file to database servers. Organizations use virtualization for their servers for many reasons, and we'll talk about some of them right now. Some companies are consolidating lightly used servers to conserve space and power. These workloads are ideal for virtual machines because you can often place many VMs on a single physical machine. So, for instance, if you have a very lightweight version or a very lightweight web server, something that's just used to get on a website and maybe it's the front end. So you have the web server and then it gets offloaded to a database. Let's say the database server is in a different virtual machine. All you simply have to do with the web server is have the web service IIS installed and ready, have a user log in, and maybe the IIS server pulls the SQL server or the Oracle server every time it needs to find something out. Make sure the username and password is correct, or whatever the case may be. Or you might have it just as an informational page where you have it connect back to a file server for documentation and things like that. So you can have instead of having a dedicated server for a very lightweight web server, you can put into a virtual machine and give it, maybe 50 gigs of hard drive space and, a couple gig of RAM, and you'll be good to go. Other organizations look to increase availability against hardware failures or complete site-level disasters. So VMs are easy to move, copy, and restore, so they make disaster recovery simple. Others look to VMs to quick provision new machines, because it's if you've taken a snapshot of a virtual machine, you can easily spin up a new one by replicating that virtual machine. So how will VMs help you? Well, I have a laundry list of reasons why. Let me scroll down here just a second. VMs and physical machines are very similar, but there are some differences. VMs can do things that virtual machines cannot accomplish. Consider the last time patch time came. You apply it and find out that it caused data or system or some sort of loss of information or system crashed. Caused data or some other. In the physical world, this results in lost evenings and weekends, and nobody likes to do that. I've been there. I've done that. I have a few dozen cans of Mountain Dew to go along with it. And you end up recovering from a backup. In the virtual world, this dilemma can be avoided with just a few mouse clicks. It's a beautiful thing. A feature called Snapshots allows you to capture the entire running state of a virtual machine, and from the contents of its hard disk to the state of its CPU and memory. Snapshots are fast and easy to use. If a patch or update does something unexpected, you can easily revert back to a point in time without back to that point without the massive time investment of doing a full system restore. If you've ever done a full system restore, it's depending on the system. If it's just a regular end user, hour and a half, 2 hours sometimes. If it's a full-blown server with many applications and a lot of resources, several hours. Snapshots are, using a technique similar to snapshots, you can take a complete image-based backup of a VM with its running, while it's running. In the physical world, we call this a bare metal backup because it allows you to restore the entire server without the need to load a recovery operating system or perform file-by-file restores. Any VM can be protected this way. It saves time and money during restores, plus you can still restore individual files. When we get into storage, you'll learn about file level and then versus block level storage. So part of the reason that VMs are so easy to back up is they're built on virtual hardware. In the physical world, you typically need to find an exact hardware match. This can be a challenge. VMs, you don't have to do that. VMs have a little to no dependency on the physical hardware, so you're free to restore them to a device of your choosing, testing your DR plan. Making it much simpler. So if you do have a DR plan and it sounds great on paper, but your boss actually wants you to test it and see if it actually works, it's very easy to do that. Whether you're backing up or backing out of a problem, VMs are able to help you. What about day-to-day requests for more memory or more disk space? Not a problem. VMs allow for hot add of virtual hardware, which means if you have if your VM's OS supports this, you can increase the capabilities of a VM without restarting it. So it's just a matter of right-clicking on it, add its settings, and then you can go in there and add hardware, more memory, more CPUs, more hard drive space. Simplifying the backup and recovery processes, you can assure management that your DR plan isn't just for show. You can actually prove it's working without affecting the production systems. That's a huge thing. So, in review, if someone deletes a file inside your VM, we need data protection, which vSphere feature can help, and that would be image-based backups. When we get into VCP, we'll talk about that in more detail. So, Esxi Hypervisor, what is that? Well, let's talk about it here for a minute. explore what the actual hypervisor is. Now, this is the actual software program that virtualizes the hardware, and then it offers it to the virtual machines so that they can operate. So the hypervisor is a resource traffic cop. Its job is to provide VMs, their virtual hardware, as well as provide the appropriate share of physical resources to the VM as defined by you and me, the VM admin. You define how much of a given resource will be allocated to a VM, and the hypervisor then executes based on your instructions. The complexity has mostly been removed through the use of vCenter Server. So when we get into it, I'll show you how to get that up and running. I just shot a video on how to get 2 virtual machines, get them situated in a virtual environment, and get them on the same domain so that you guys could see how that works. There are 2 types of hypervisors, and this is where people sometimes get lost. Type 1 hypervisors are called bare metal because they are installed on a physical device without an OS. So, for instance, if you have a hard drive that's blank, it doesn't have an operating system on it, and you want to virtualize things, virtualize servers or computers or whatever the case may be, you can load VMware's Esxi, whatever version you want, and it will be able to be installed directly onto the hard drive the same way that Windows Server, Windows Desktop, Linux, Mac, the same way. You'll be able to install them directly to the hard drive, and then once Esxi is installed, there will be an IP address that's given to you, and you'll be able to log into that box, download the vSphere client, and then start doing whatever it is you need to do. VMware Esxi is a Type 1 hypervisor. Type 2 hypervisors is called hosted because it operates as an application on top of a pre-existing operating system. Vmware Workstation, the actual way that I'm working with the VMs in this particular series, is a Type 2 hypervisor. It runs on top of Windows operating systems. So I have Windows 7 as my main operating system. I have VMware Workstation installed on my local computer, the one I'm recording on. I also have Windows Server 2008 R2 installed on the server that we're doing all the virtualization on, and I have Workstation there installed. The reason I did that is because of the fact that the VMware license is good for 60 days. I don't want to have to, every 60 days or 58 or 59, go in and wipe it and bring it back up, because then you lose your virtual machines. At least because I haven't figured out how to move them yet and all that other good stuff, it's easier for me just to have it set up the way it is, and then I can spin up new servers. However, this is where it gets pretty good. Vmware Workstation is a Type 2 hypervisor. You can run a Type 1 hypervisor inside of a Type 2 hypervisor, meaning I can install Esxi 5.5 inside of VMware Workstation, and it does work. So, since Esxi is a bare metal hypervisor, it performs the role of resource management while enjoying direct access to the underlying physical hardware. You can improve your resource efficiency because there is less operating system overhead. The stability of your Esxi hypervisor isn't dependent on another operating system. Esxi is commonly installed on a hard drive in your physical server, and it can be installed into flash drives, SD, and USB drives. You can also network boot an Esxi host using traditional boot from network tools such as Pixie and TFTP. So, I haven't actually done that yet, but there is a way, and if you're doing it this way, you could actually have a Pixie stands for pre-execution environment. What that basically means is you're able to install an operating system. So, like if you were to take an Esxi server and you wanted to boot it, or if you wanted to install a new operating system inside of Esxi, you could set up another server to be responding to Pixie boot requests. So as soon as the computer that you're trying to install sends out the request for DHCP, and there's a DHCP server listening, you can go in, and as soon as the DHCP server responds to the request, then you can start downloading the operating system and stuff like that. That's how a lot of the VMs, the desktops and servers that we work on where I work, that's actually how we deploy operating systems. We won't take the disk with us. We'll go on the network. We'll F12 for a network boot. We'll wait for the Pixie boot to happen, and then we'll use Windows Deployment Services and SCCM to deploy the operating system. It's WDS that houses the actual operating system, and then you use SCCM to determine which operating system you're going to install, and then you name it using the OS CD, and it's the Operating System Configuration Dialog, I believe it stands for. And basically what you're doing is you're naming the device so that you can, when it's being installed and the kickoff happens, it can be placed in the correct organizational unit, or OU, when you are done installing it, and then you can move it to whatever OU it needs to go to. Host management. While virtualization is advanced, VMs still need user interaction to install the OS, application, and data files. Through ESXi host, you can create new VMs, just adjust their config files, monitor performance, and even control the VM remotely. This works well if you have a single ESXi host, but if you have more than just a few, the management can get complex. So now you have multiple consoles open and several servers to manage. You really need to take advantage of some advanced features of virtualization, and a centralized management solution, vCenter, is needed. And that's actually what ends up happening. So, like I mentioned in a previous video, if you have a physical server, you load ESXi to it on the hard drive, and you start adding virtual machines to it. They're in production, they're working, and then you add a second physical server, load ESXi to that one as well, start adding virtual machines. Then you have two ESXi hosts. In order to log in and manipulate a VM on host 1, you need to go to the vSphere client of VM1. Same thing with VM2, with host 2. You need to log into these guys. You're going to have two ESXi windows open at the same time, or vSphere windows open at the same time. vCenter allows you to take those same hosts and join them in the same location in vCenter. It's just like Active Directory. So if you've ever played with Active Directory, and you don't have to have a domain controller for every location. You can have one domain controller and then a couple of read-only at your branch sites, but it allows you to take and centralize the management of your network and your administration, because having to go to multiple servers or multiple hosts to take care of whatever you got to do, that's time consuming. So from here on out, this is the end of that video, because that pretty much brings you up to speed on ESXi. I'm going to talk about vCenter in the next video and its components. This is going to take a big chunk of the time, because this is where the meat and potatoes of the series is going to come into play. So I hope this has been informative for you. I want to thank you for viewing.